Welcome to the Brainstream. I'm Colin, here with my co-host Harrison.
Hello, hello.
Today we are going to talk about neuromarketing with Brainamics, a neurotech startup spun out from the Technical University of Munich. Brainamics is a neuromarketing company that uses a unique technology framework that enables the extraction of emotions directly from the human brain. To do that, Brainamics uses electroencephalograms, or EEG, and machine learning algorithms.
The commercial starting point for Brainamics was the gaming industry, where game developers use the insights into psychology and user experience of their games to optimize their gameplay. The vision of Brainamics, however, reaches far beyond that, and they hope to do much more with neuromarketing in the future as the field advances. Before we move on, though, let's define neuromarketing. So neuromarketing loosely refers to the measurement of physiological neural signals to gain insight into customers' motivations, preferences, and decisions, which can help inform creative advertising, product development, pricing, and other marketing areas. So this is a pretty broad field that's sprung up mostly over the last decade. So again, the main theme is that they're using brain sensing or even just biological signal sensing to determine if someone is interested in a product, maybe through an ad, so they can kind of look at your brain waves and see, oh, maybe they're interested in this point of the ad, or maybe they're bored. You can also use that for user experience testing of different products. So primarily they use fMRI, so looking at activity in the brain using an fMRI machine. But those are pretty expensive, cost about $5 million for an fMRI machine, so usually they'll rent them. Or they can use EEG. But in addition to that, sometimes they'll use PET, which is another type of brain scanning technology. The machine kind of looks similar to MRI. MEG, which is similar to EEG, and FNIRS, which again is measuring a blood flow response, but they can also do things like measuring the galvanic skin response and just other types of biosensing to try to get a holistic picture of what that person is thinking and feeling as they're interacting with a product, ad, or in this case, video games.
Yeah, so this is all towards the aid of making more engaging media, making more engaging ads, more effective ads, and assessing effectiveness of existing media, brands, that sort of thing. It's a really interesting field, and we had a great discussion with them. Let's get into the discussion.
Hello, everyone. We're here with Vlad Samoilov, the CTO and co-founder of Brainamics, and Philipp Zent, the CEO and co-founder of Brainamics. Welcome, guys.
Thanks for having us.
So if you could just start in a few sentences, just tell us, what does Brainamics do?
All right. So Brainamics in itself is a neurotech and neuromarketing startup based in Munich. What we developed is a technology to translate the raw EEG signal into emotion, concentration levels, and any useful measure for end users. And we developed a software for that and made this software hardware independent so that we can not only use it on a specific hardware such as the OpenBCI one, but on any one.
Very cool. And what do you guys use that emotional gathering for? Like for example, is there anything specifically that you then tie that information to later?
Yeah, so our first commercial use case was in the gaming industry. So in gaming, there's this process called playtesting. So before you publish a game, you want to make sure that the user experience that is elicited by the game is on point and that the players are going to have fun playing the game. And typically you do surveys or verbal interviews with the testers, with the gamers, but you always lack some objective feedback. And that's where our technology comes in quite handy, because we can objectively tell how the players felt during every single second of the gameplay. So that's kind of why we support game studios and also game publishers in leveling up their user research methods by using our technology.
That's a good tagline if you use that, leveling up their research.
Hi, my name is Vlad. I'm a CTO and co-founder of Brainamics, responsible for developing the technology, also for products.
I'm Philipp. I'm the CEO and also the co-founder of Brainamics, and I cover a big part of the things that Vlad is not covering. And then also worth to mention is our third co-founder, Tim. So he's not in the podcast today, but he's taking care of all the operations of Brainamics. So whenever we do any customer project there's a huge operational overhead, and he's responsible for that part.
So one thing that I noticed when looking into your backgrounds is that neither of you have formal backgrounds before Brainamics in neurotechnology or gaming, or maybe even marketing. And so I just thought it was interesting. Philip, I saw that you have an MS in management and technology and a bachelor's in economics and finance. And Vlad, you've received an MS in particle physics, worked in data science, DevOps, quantum optics. So you guys are clearly very smart, but again, that doesn't seem like neurotech or gaming. So what was the spark that led you to start Brainamics? How did you find out about this technology, and what did you need to learn to transition into this field?
So I guess I can start with this. So for me, I mean, to be honest, it took some time to find my passion. So I initially started with theoretical physics. I really love physics and mathematics, but it wasn't quite my passion. So I decided that I don't want to go into academia, that I just like building cool stuff, and I was exploring different topics, like you said, DevOps or quantum computing. But then I just thought, okay, what will be like the most disruptive and the coolest technologies that I could work on? And then, actually, brain-computer interface directly came into my mind. So I decided to start working in this direction, took some courses in the university, and then during one of the hackathons, there was a invited guest. He gave a lecture about use of brain-computer interfaces in gaming, and one of those was playtesting. And I thought, okay, it's technologically feasible, and as a gamer, it's really I like this use case. And then I just started working on it, and then I met Philip. So I just reached out to him and said, okay, I have this idea. You want to join? And he said yes. And I think I was very lucky that I met Philip, because he took care of all the business and client stuff, and I could focus on tech development.
Very cool.
That's fascinating. And what does your third co-founder do?
You mean in terms of background, or what he's doing in our company?
A little bit of both.
Okay. So he's like a chief operating officer. So he's taking care of all the operations. When we do the testing with the customers, we need to invite a lot of testers. They need to fit the target audience of the game. So that's really crucial that we find the right people there. So identifying them, inviting them, making sure that all the operations run smooth, because there's also always a time pressure. So when the customer comes, they want to have results in a couple of days. So this process needs to run smooth and needs to be as much automated as possible. So it's a very tough challenge, especially from a management perspective. So that's what he's responsible for. And his background is in business administration and in automation, like business intelligence, business automation. And we actually met, so Tim and I, we met together when we did an internship in another startup here in Munich. We directly clicked. And for me, it was clear that he will also click with Vlad, and that's kind of how the founder team came together.
That's fascinating. And so that wasn't even that long ago, right? You were founded in 2021. Is that correct?
Yeah. So Vlad started this hackathon where he actually won the prize as well in 2021. I think it was March, something like that.
Yeah, I think it was March 2021 or April 2021.
Yeah. And then I joined directly after that. And in August, I met Tim also last year. So that it was a side project for many, many months. And then we saw, okay, there's a lot of interest from the customer side when we did the customer discovery. So our first step, after we saw that it's technically feasible, we did a lot of customer discovery. So we interviewed end users, right? So the game designers, the game's user researchers, and so on. And there we already saw, okay, they would be actually buying the stuff that we are trying to sell. Also at the same time, the founders of the startup where I did the internship said, hey guys, this is such an amazing idea. Can we invest? And kind of those two things coming together. And also we won a lot of startup prizes and everything. So all those things coming together, we said, okay, let's give it a shot. Let's focus full time on this. And we then really founded the company in March this year. So we are still very, very fresh. Founded the company just half a year ago, basically.
Wow. That is incredible, seeing how much growth your company has had. I mean, even in that time, in the last several months since March. So can you tell us how much have you raised in that time, and how has the team grown?
Yeah, so we started directly after founding the company with a angel round. We collected in total around 500,000 euros in funding. And yeah, the team grew since then, especially on the tech side. We have a very strong data science team by now. And we also hired some people who are experts in neuroscience. So Franz is our latest hire. He's a PhD in computational neuroscience and brings this seniority and the expertise both in AI and in neurotechnology to the team, which is really beneficial. And yeah, for the fundraising timeline ahead, we are fundraising again at the moment to grow even faster. And this time it's going to be a little bit more. And maybe by the release of this podcast, maybe we already closed the fundraising round. So we are pretty far advanced in the process now. But yeah, cannot share too much information on that yet.
Oh, that's exciting though. Yeah, congratulations, especially in such a difficult time to raise money. You guys are doing great on it.
So there's so many different use cases for brain-computer interfacing and EEG technologies. What specifically made you guys so interested in neuromarketing, and why did that seem like such a powerful use case for you guys?
I think it mostly is the question of technical feasibility. So, of course, everyone wants to do control something with their brains or, something in this direction. But we thought that extracting emotions is actually technically possible now. So we did a hackathon together with the group that is specializing on motor imagery. And there I saw how much hassle it is to work with motor imagery, and it doesn't really feel like a true brain-computer interface. You need to imagine that you move your right hand, left hand, or legs, or something like this, and control something through this, and it's not that intuitive. And emotions, they seemed easier to extract, and also the use cases were right there. So everywhere in all the applications, in all the games, you have user experience that needs to be measured, that needs to be improved, and so on. So there was a clear demand for this information, which is not the case with motor imagery, for example. And this both pillars, so to say, of technical feasibility and demand, made us focus on neuromarketing.
Gotcha. Seems like there's more scientific precedence potentially too for these sort of things as well, which is interesting.
Yeah, true. So of course we did a very thorough research in the literature of how to develop this technology, and we saw that that emotion extraction is already kind of there. So it's not at the production level, but research was pretty abundant on this topic. And on the motor imagery was also abundant, but again, it's not. It doesn't
unreliable
brain-computer interface. Yeah, even if it's reliable, okay, there are like 2 degrees of freedom. You can move left and right, for example, or up and down, and that's it. So it's not a nice improvement of user experience.
Awesome.
So how generalizable is this emotion information that you're getting from people? Because I've read papers on emotion sensing from EEG, and it's definitely been proven to be possible to an extent, but it seems like there's a lot of variability, and it's kind of a tough thing to go after. So when you're bringing people in, how are you sure that this is frustration or excitement or whatever it is in that person?
Mm-hmm. Yeah, this is a very good question, because this was actually the biggest challenge that we had to overcome to bring it to production, to actually do it at scale. Because in all the research, you find these papers, okay, they did 10 people, 20 people, and they reach high accuracy, but then, it doesn't mean that it will be generalizable for a large population. And since we are doing a lot of tests, we have always very different requirements from different customers. We had to make sure that our technology is applicable for every new person coming in for the test. And I think so the 2 main things we had to do is first to gather a large enough data set that covers a lot of different people. And we started basically from day 1 collecting data, and by now we have something like 200 hours of training data, and from a very diverse demographic. So we have male, female, different ages, different backgrounds, different personalities. So to cover all this, so cover as much ground as possible. And then on the other hand, at the same time, we were working on normalization of this data. So because when we want to feed it to the model, it needs to kind of predict on the same distribution that it does for training. So we use some tricks there. I cannot really disclose a lot of them, probably not any of them, but yeah, we did a lot of normalization. This is the biggest part of our pipeline. So in our pipeline, most of the stuff is like pre-processing, normalization of the data, unification of the data, and then only like smallest part is the actual training.
Gotcha. Filtering, that sort of thing. What sort of technologies specifically are you using to pick up this data? So obviously you're using the EEG to pick up brainwave signals. Any other types of technologies that you're using in concert with that? What specific EEG devices are you using? That sort of thing.
Yeah, I can take that. So besides, so which EEGs do we use? We started in the beginning with the GTech Unicorn. We then moved to the OpenBCI, so we both tried the passive and active one, and the active OpenBCI so far is the one where we see the best results. So we're at the moment using that one. We also looked at the Muse, not as nice in terms of accuracy, what we can achieve there. But in general, we're always looking at different EEGs. Also, a friend of us here in Munich, he's developing his own EEG that he wants to start selling through now. So yeah, we are always up to date there. And besides the EEG, we are looking at different biometric sensors as well. Eye tracking is always included simply because of the additional use that it depicts for our customers. Then also we record the face of the player with a 4K camera. And now we're also looking more into the field of multi-modular sensors. So we want to maybe also measure the ECG, so the heart rate, the galvanic skin response. Those are things that especially our latest hire Franz is now looking into. So we want to have like the most sophisticated and comprehensive picture in terms of biofeedback that we could get.
Very cool. That's good to hear. We were actually just at OpenBCI a couple weeks ago recording a video for them. I'm a former intern for them, so it's good to hear that you guys are getting good use out of their technology.
Yeah, especially the Project Galea is really interesting. Like the merge of the VR headset and the EEG, I'm really curious to see what are the outcomes of that. And we also probably next year will start some research collaboration with them on that.
Connor's a visionary.
Yeah, when we were actually at OpenBCI, Connor mentioned you guys, so I thought that was cool. Because I was like, oh, we're very soon we're going to be talking with Philip and Vlad from, and I like paused for a second. He was like, Brainamics. So I was like, yeah.
So that's good. Yeah, we were actually like, since we are fundraising, we also talked to the investors that invested in OpenBCI, and that's how they connected us. So we already had a talk with those guys. So really nice. Yeah, that's cool.
That's cool. So we've just talked about a lot of the different technologies that you use to collect data, but how do you bring this data together, and then how do you analyze it and then make it actionable for your clients? You have all this data. How do you say, okay, this is how you can actually improve your game from this?
Yeah. So yeah, well, maybe first we can cover the processing pipeline and the training, and then go into how we do it, how we make it actionable. So yeah, first of course we got just the raw data from the headsets, and we somehow need to translate it into emotions. So this is the first step. And in this process, as I described before, we need to do a lot of pre-processing, filtering. Unification of the data is important so that we can work with multiple headsets. For example, we developed some algorithms that allow us to train the model and do inference independent of the electrode number. So for example, we can have training data from 16 channels, from 8 channels, from 32 channels, and take all of this data and then train the models, and then do the inference on 8 channels or 12 channels or whatever. So we have completely headset agnostic models. And the emotion classification we do based on the arousal and valence scale. So we we chose this model because it was most abundant in the literature, most studied, and basically our model for every second of the game predicts these two numbers, so arousal and valence. Arousal describes how, in general, active our nervous system is, how aroused we are, how awake we are, and valence describes like the hedonic pleasure, so how pleasant the experience is, or that the person is experiencing. And then we take these two values and do further analysis on it to create actually actionable items, because what we realized is that just giving game developers these graphs of arousal and valence is not enough. So it needs to be analyzed and transformed.
Gotcha.
Maybe to add on that, so there we look into, we always try to map the emotions that we extract, so in terms of valence and arousal, to KPIs that are relevant for the game developers. So especially the mobile gaming industry is really KPI driven, as you can imagine. So they always want to understand how does this emotional response correspond with a churn, with retention, and so on. So we always look at, let's say in the example of churn, they know when the players churn, but they don't know why. And what we can easily show them is when do they start to get frustrated, or when do they start to get bored. It could be like 5-10 minutes before they actually churn. And this can never be found out with like quantitative studies or market studies, but we can easily show, hey, the players get bored 5 minutes before encountering this certain level, and then they churn. So that's one of the unique insights that we generate through the valence and arousal values that we extract.
That's really interesting. So you can literally have somebody like trying to solve a puzzle or something, and then maybe they're unable to solve it. And you can pick up the fact that they're frustrated that they can't solve a particular puzzle, and then say, this is the specific problem that this puzzle has, and then give that feedback to the developers.
Yeah, exactly. But I mean, with the frustration there, you also need to be a little bit careful, because initially you would think, or intuitively you would think, that frustration or negative emotions are always bad. But in fact, in the game design, the game designers really aim for also inducing some frustration, some sadness, to have like a more holistic user experience overall. Because the more you get frustrated at some point, the happier you will be once you solve this puzzle. So it's just about finding the right balance. And by looking at the data that we provide them, it helps them to better understand what is enough, what is too much.
Super interesting.
Oh, yeah, it's basically all based on the motivation and the contrast. So what you want to achieve in the game is to have a high emotional contrast. That's what also we thought of initially. So when we started working on it, and that's what our data shows now. So we now have data from a lot of games, and we can see that the good games, they actually have a higher amplitude of emotion. So they achieve a much higher contrast in terms of frustrating players and then rewarding them, then frustrating and rewarding them again. And it all ties up with the gameplay loops. So in every game you have basically a gameplay loop that the player needs to repeat over and over again. And example of the gameplay loop is, say, in Skyrim, you walk around, you discover some interesting cave, you go there, you fight monsters, and you at the end you get some loot, and you feel rewarded that you get some loot. But to get to this loot and to feel actually rewarded for that, you need to overcome some challenges first. And so the gameplay loop emotionally consists of just some relaxing experience, so relaxing exploration first, then challenge, and then reward for getting the loop. And that's what we quantify for our customers. We can summarize this data from multiple testers, from multiple repeated gameplay loops, and we can see if it works properly. So if people are challenged enough, but not too much, if they get rewarded enough, not too much, and from that we can deduce if they have a motivation to repeat this gameplay loop again. So if they're motivated to do it over and over again.
Very cool. Scientifically determining that carrot and stick problem, right? Very interesting. So let's imagine Harrison and I are a client for a gaming company, right? And we have a game that we're bringing to you, and we're looking for playtesting on that game in order to determine, how we can improve the game, that sort of thing. I guess the first part of that is gathering data, right? So what does a Brainamics data gathering session look like in terms of who comes in and puts on these headsets? What do the headsets look like? And then, how does that data gathering start? And what does that whole process look like?
So once the customer decides to go with a test with Brainamics, they have a kickoff meeting with us. They specify their target audience for the game, so their psychological profile, their motivational archetype, and also the demographics, which type of games they like, and so on. Then we automatically inform those testers in our database. They get invited to come to our office and do the testing. In the meantime, the customer sends us the game build, and then once the testers are here, they play the game. While they play the game, they obviously wear the EEG. So at the moment, the active open BCI that we use. At the same time, we record all the other biometric sensors like the eye tracking, face, and so on. And then once this session is over, we start with the analysis. So first we extract emotions, render all the videos, and then we start with the analysis. And what's also worth mentioning during the gameplay session, so before and afterwards, we always calibrate for each tester to have like an emotional baseline. So it might be that you come in extremely frustrated or extremely happy for whatever reason. And this kind of needs to be filtered out, right? So we always do this baseline calibration. And yeah, after the gameplay session, our user research team basically analyzes the results that we generated, and the customer then receives all the raw data that we have. So in terms of emotion, rendered together with the gameplay. And on top of that, they receive this in-depth report where we give them the actionable items on churn, for example.
Very cool. So at what point do the customers actually get access to that data? Is it sort of live as you go, or do you set up like a report or something after the fact? Do they get access to the raw data, or is it just sort of a like a report, like a PDF that breaks down, this is when this happened, etc.?
So they receive the full access to everything. And sometimes we have customers who are really, really fast paced, and they directly after the playtest want to see already the gameplay, although we didn't have the time to make the report yet. And then they receive the report a day or 2 days later. But typically, we just give them access to all the results, including the report, together. And this is typically a few days after we recorded all the gameplays. But there again, there's big differences between mobile games, because they always just want to test like 20-30 minutes first-time user experience, and AAA PC console games, because they sometimes have 8 hours of gameplay or even more that they want to test. So getting those recorded and analyzed takes obviously way more time.
Interesting. So how do you pitch this concept to potential clients, to game developers? So obviously playtesting is something that has been around in the industry, that's validated as important, but now you have this neurotech component that you're adding. So how do you pitch that to your clients, and then what reactions do you get?
Yeah, I guess that's also a question for me. So I'm also taking care of the sales for now. So how do we sell it? In the beginning, we basically just sold it as an add-on tool to normal playtesting. So, hey guys, you can do your normal playtesting, and then we provide you some more fancy insights. But what I quickly realized is that the customers, they don't want to modularize their playtesting. They want to have this one-stop shop, basically. And that's why we moved more and more towards integrating our technology into the normal playtesting process. So now we also do the surveys that we include in the playtesting, and we look at usability aspects, so all the, let's say, more conventional things that game studios looked at, and integrate our service on top and sell it as the USP, basically. So everything that you get through the normal playtesting is way easier to understand and way more sophisticated through the biometric feedback that we generate for you. And we always show them examples and case studies of previous tests that we did, and also the comparison between the KPIs before a test and after a test with Brainamics, after you implemented the suggestions that we come up with during the playtest. So this sells quite well, I would say, on the one hand, because the technology obviously sounds extremely fascinating and fancy, and on the other hand also because we already have some nice names in our portfolio, like good brands that everyone knows. And yeah, together this makes it quite easy for us to get new customers.
Yeah, actually, maybe from my point of view, it's the case, but it seemed like people are eager to try it because they see directly the value. They see, okay, we were struggling with understanding our players for so long, and now these guys can directly tell us, okay, what they feel, what is in their head. So of course, Philip was taking care of sales. I'm not sure how difficult it was actually, but from my view, it was so. It was not as difficult as I would expect, because people are really excited when you tell them about this. They're like, "Oh wow, I couldn't even imagine that's possible. Here, take my money." So that was my view.
Very cool. Is there any way that this technology can be applied outside of just playtesting video games?
Yeah, definitely. So for us, the gaming is the first vertical, obviously, but we are already in the preparation for a pilot in a new vertical, which is going to be commercials and advertisement production. So we see there a huge potential as well, because there the emotions are even more important than in games, because they have 30, 60 seconds maybe for an advertisement clip. And in those 60 seconds, you need to hook the target audience, right? So they need to be excited about whatever you're trying to sell them, which is why we see the huge use case. So we're just exploring that now. Besides that, also movie production, of course. So everyone has been in a test screening. You could also apply our technology there and add some more useful insights to just service that you fill out normally there. And in general, wherever you have the digital user experience that you somehow want to test and optimize, Brainamics solution could be of additional use. But also, since we are a small startup still, we don't want to put too many eggs in our basket. So we try to really become good in the gaming use case, and maybe explore one or two more use cases that are rather adjacent to gaming, but not do something completely different for the time being, at least.
Very cool. So we could do things like you potentially analyze YouTube videos, like BCI guy videos.
Yeah, exactly.
Hint, hint.
Yeah. And so this would be obviously the next cool use case. So seeing when the target audience gets bored and when they are most excited, what's most interesting, this would definitely be also something that we could do. And maybe let's talk also a little bit about our long-term vision. So thanks to the biometric data that we are collecting, we are building the basis to develop rather groundbreaking technologies in the field of neuroscience and neurotech. So for now, as we already said, we have this neuromarketing use case, which is technologically rather feasible and not too complicated. Anything that rather goes into the general purpose BCI direction, so where you can control your smartphone or computer by thinking, requires, on the one hand, of course, way more technological advancements, but on the other hand, also way more data, especially if you want to do it non-invasive, which is always our goal, to stay non-invasive. And therefore, it's really nice that we can already now build a solid business, get some solid revenue, and at the same time collect a lot of really useful and diverse data through gaming, through marketing clips, whatever. And this will bring us step by step closer to the long-term vision. And even to stay within the gaming space, we are really hyped about the idea of implementing adaptive experiences, so that when you play a game, let's say with the Galea from OpenBCI, and the EEG detects that you kind of get bored, then they may just spawn more enemies or change the audio or some visuals to make it more exciting for you, to like spice it up. And this can really, really bring any type of user experience, especially in gaming, to the complete next level. And this is a few years down the road still, but this is definitely something that we want to push into once it's possible.
So adaptive gameplay based on like emotional arousal, pretty much.
Yeah, you could say so.
Reminds me of the Left 4 Dead AI director thing, but like on a whole different level of like actually reacting to brainwaves directly. That's really cool.
What was that, Colin? Could you explain it?
Yeah, so the Left 4 Dead AI director basically is an AI that reacts to how a team is performing in the game, and then makes the game harder or easier depending on how the team's doing, essentially. So like doing that, but with brainwaves and other biometric data. Very, very cool.
Yeah, this example was actually in the talk that initiated this whole idea. So there was a guy from Valve who was talking about BCI in gaming. And when he was talking about adaptive experience, this is the example they brought up, because that's what they did in Valve, and he kind of speculated that in the future it could be done with brain-computer interfaces, and that's one of our future technologies that we want to bring to the market.
That's awesome. I see the vision there for sure.
So I see on your website that you have this future roadmap that goes up until 2030, and you have a lot of exciting milestones on there. So can you tell us what is the future in your view right now of Brainamics?
So, this spiral starts with emotion extraction. So as Philip described earlier, the difficulty with brain-computer interfaces is that there is just not enough data for some super exciting application. So it's kind of a death loop of BCI. So to develop some cool applications, you need a lot of data, but to have a lot of data, you need to have a lot of users, but to have a lot of users, you need cool applications. So it's kind of you're stuck there without data, users, or applications. That's why we kind of invested first into collecting our own data and creating emotion extraction. And while we are doing this neuromarketing and gaming, we save all this data to use it in the future for future applications. So, and the next step that it is written there as UX prediction platform is basically now so we collected a lot of games. I don't even know how many. I lost count for sure. And we have the emotional data from all those games, and we have also the KPIs from this game. So how well they perform, their their sales numbers, their retention dates, and then basically based on the emotional data, based even only on the first time user experience, we can already predict for our customers whether this game is going to be successful or not. So this is the next step that we are actually already almost achieved. So we're doing some pilot projects with some of our customers to predict the success of their games based just on like first time user experience, first 30 minutes of the gameplay. Already predicts a day 7, day 30 retention, just because we have a lot of the data, a lot of the relevant data that can be used for prediction. And what was the next one?
Adaptive experiences.
Yeah, the adaptive experience we already discussed. So it requires some patience, I guess, because the hardware is not there. For adaptive experience, we need people to have the hardware then while they're playing the game. Galea is the first step towards it, and I hope and we really hope that soon new players will enter this market. And and the last one is Brain Copilot. It's actually just shoot for the stars, but it's actually how we imagine the actual brain-computer interface to work. So, for example, you know about Copilot from GitHub, where there is code auto-completion, and we think that it's going to be much cooler if this auto-completion comes just from your brain intentions. For example, even if you just scroll the Instagram, there is just, based on your usage history, there are just a few directions where you might go from this. So, for example, the app collects a usage history, and it knows that, okay, there is 80% chance that you will continue scrolling, 10% chance that you will write a message or put a like, and maybe 10% chance that you'll quit. And then it takes this usage experience, then takes also your brain data, and then machine learning model adapts the probabilities for the next step based on your brain data. So this is kind of a copilot, this model that just runs in parallel, reads your brain data, reads what's happening, and then tries to predict what's going to be like your next step. So it's not direct control like with motor imagery, where you directly think, okay, move right hand means like opening this up, move left hand, opening this up, but it's a very indirect and intuitive control. And this is, in our opinion, how the brain-computer interface actually should work in the future. So there is some app that you are using, there are some degrees of control, and that your copilot, this model copilot based on your brain data, tries to predict what are the actions you actually want to take. So this is the final, so the actual general brain-computer interface we want to arrive to.
Sure. That's such an exciting future, and it's really interesting seeing all of the different aspects that your team is working on. And again, the incredible growth that you've had in such a short period of time. Without knowing that, I would have thought you've been around for a decade already. So so congratulations to your team. And I just think neuromarketing, these concepts in general are so interesting. Like you tapped on earlier, it's not really something that you can spoof or that you can hide from. It's your emotions, right? And you know, in traditional play testing, you might have someone do a survey, and they either might not be 100% truthful about that because maybe they're embarrassed or they don't want to offend you or the game developers in some way, or maybe they just don't remember certain parts of the experience or aren't able to represent that well into words. And so it's so cool to have those time-stamped emotional events that you can point to, and I think that's really interesting.
Yeah, you basically described what we should have said in the beginning about the neuromarketing, but we actually have a nice story about that. So when we just started adding the surveys to the test, there was a girl we tested with, and she really didn't like the game, and she was filling out the survey, and it's like, no, I hated this game, but I'll put it 4 out of 5 because I don't want to have any problems. We're like, oh, no. If you didn't like the game, put 2 out of 5, 1 out of 5. It's like, really put what you felt. She's like, no, I'll put 4 because I don't have problems. We're like, okay, we have your brain data, put whatever you like.
That's funny. Well, anyway, thank you so much to Philipp Zent and Vlad Samoilov, the CEO and co-founder of Brainamics. You guys have been amazing, and this is such an interesting conversation. Thank you.
Thanks a lot for having us, and I'm looking forward to a potential next episode at some point, or even testing your YouTube videos with our technology to see which users react in which way to your content.
Yes, please. I mean, personally, I can't think of a more important application of this technology.
Thank you so much for your time. We really appreciate you.
Yeah, thank you.
Thanks, and take care, guys. Bye-bye.
Bye-bye.